Chains are as indispensable today as they were thousands of years ago. Ancient historians refer to the use of metal chains for jewelry, shackles, and construction. Today, chains are used for those very same purposes and many more. Chains are a link with the past, one that we're unlikely to break. Chains are used to tie things down, hold things together, and pull things along. And their many sizes reflect the varied uses. To make a chain, a turning drum uncoils this wire rod and pulls it through a steel guide ring to a steel draw box. Grease inside the box lubricates the wire. On its way out of the box, the wire goes through a die, such as the one being demonstrated here. The die has a smaller diameter than the wire, and as the turning drum pulls it through, the wire narrows, hardens, and becomes stronger. Now, electrically driven tools move in from all sides. This is a forming machine. A tool called a jaw propels the wire forward, while another jaw pushes on the wire, bending it around a steel pin. It forms a C shape. Another forming tool closes the C, completing one link in the chain, and then another jaw makes the next link. This machine is making jack chain, which is usually used to hang lights. Another forming machine makes a chain that can haul a heavier load. A grip pulls the wire onto rollers that straighten it out. Steel cutters now make notches on both sides of the wire. These notches mark the place where the wire is to be sliced into link-size pieces. A mechanized knife makes the final cut at the notches. Next, roller arms loop a cut piece of wire around a steel finger. The roller arms make it look easy, but they're actually exerting tons of pressure in order to shape this wire. After the rollers form the link, a pliers-like tool grabs it and turns it around. This positions the completed link so that it can connect with the next link as it's shaped. As each link is added, the chain drops into a pile below the machine. There are dozens of forming machines in most chain factories. Each machine makes 50 to 60 links per minute. That's approximately 76 meters of chain per machine per hour. To put that into perspective, one machine could make a chain as long as the CN Tower is high in just 7 hours. After the chain is formed, it'll need to be strengthened. So it's onto the welding machine. Hammers to the left and right push the link in. Then 2 copper blocks move in from the sides. They act as electrodes and zap both sides of the link with an electrical current. The current ripples through the gap in the link, while the hammers push it in. The link reaches a scorching 927 degrees Celsius. The wire melts, and the link fuses together. Now a pulley system drops the freshly welded chain into a heat treating coil. An electrical current runs through the copper coil, heating the chain inside until it's orange hot, 940 degrees Celsius. The pulleys lower the chain into a tub of water to cool. The extreme temperature change alters the molecular structure of the steel, making it much harder. But the experience leaves the chain a bit brittle. So it goes into a second heat coil that's not as hot as the first one, and then into another cool bath. This takes away the brittleness and gives the steel a bit of stretch. Now the ultimate strength test. This is the chain calibrator. Pulleys run the chain into a groove that's been cut into a block of steel. A clamp on the left holds it in place, while the hydraulically powered block of steel pulls the chain to the right. Will it break or will it hold? And can it handle the load? After all, you're only as strong as the weakest link.